Hello everyone, welcome to this talk that will be about Thoth's improvements in OpenShift Python s2i build process. This recording was created for DEF CON VUS, that is virtual event for 2020. I hope you are staying safe. My name is Fridolin and welcome to this presentation. Let's move on to agenda and let's take a look at what we will discuss in this talk. So first, we will take a look at what s2i is and how OpenShift s2i process works. And I will explain how to turn your Git repository into a container running inside an OpenShift cluster. Then I will list existing solutions for OpenShift Python s2i, and we will move on to Thoth. I will explain basics of Thoth, Thoth's mission, and following that, we will explain also why Thoth needed its own OpenShift Python s2i. Then we will explain Thoth's addition to Python s2i, what is baked in, what it offers to you, and how you can use it. At the end, I will link some URLs to existing resources, to web page we have, and also to organization on Quai, where you can pull container images that are Thoth s2i enabled. So let's start. So what is s2i? s2i stands for source to image, and according to OpenShift's documentation, it means source to image is a tool for building reproducible Docker formatted container images. It produces ready-to-run images by injecting application source into a container image and assembling a new image. The new image incorporates the base image, or so-called the builder, and build source, and it's ready to use with build run command. s2i supports incremental builds, which reuse previously downloaded dependencies, previously built artifacts, and so on. So this is based on OpenShift's documentation. But let's take a look at it more in depth. So s2i is a way of building container images that are subsequently run in an OpenShift cluster. This is a build process that can turn your Git repository into a container image. You just need to follow some very easy to follow conventions, and you can easily turn any application that is living in a Git repository into a container if you follow this convention. In the worst case, you need to add some more things, but it's quite straightforward. These built container images are then deployed and run inside an OpenShift cluster with native support in OpenShift, and you can very easily scale these applications that are built using s2i, and you can benefit from cluster deployment and all the things that are with it. So imagine you are a developer. So what do? You create a Python application and you push it to Git repository. If OpenShift cluster is configured, it can automatically build a container image using sources that are present in the repository, automatically based on triggers that are coming from this Git repository, or you can manually start the build process. This build process is running inside an OpenShift cluster, and it results in a container image that is subsequently pushed into a container registry that can be, for example, OpenShift's internal container registry. Then you can deploy your application, or this application can be also manually deployed based on triggers. So once the image is pushed into the container registry, the application automatically deploys and is available to users. So this is basically high scope or high overview of OpenShift s2i build process. There are already existing solutions, so if you want to use Fedora-based s2i container images, you can do so. You can pull them from registry.fedoraproject.org, And there are available container images with different Python interpreter versions and also with different Fedora as a base operating system or as a base container image that is used. You can also use UBI. UBI stands for Universal Base Image container images, and these are available in Red Hat's catalog. And again, you can find different versions running different Python interpreters. So here you can see listed Python interpreters in version 3.6 and Python interpreter in version 3.8, both running UBI 8. And you can also find older versions like UBI 7, or you can also find container images that are running legacy Python 2.7, if I remember correctly. Besides that, there are Thoth s2i container images. You can find listing of these container images in s2i Thoth repository in ThothStation organization GitHub. These container images are automatically built and available inside s2i, so you can pull them from these links. You can find more up-to-date information, or more up-to-date listing of these container images in the s2i Thoth repository in ThothStation organization. So that's it. And we will focus on Thoth s2i container images as of now. So why Thoth's addition to Python s2i? Before we start that, let me explain what is Thoth. Thoth is a project in AI Center of Excellence, or AI COE organization in the office of the CTO, Red Hat's office of the CTO. Our goal or our mission is to provide some tooling and also some platform that would make OpenShift a better platform to run AI and ML workflows. So you can imagine that Python is the driving force for AI ML applications as of now, and thus we use Python as a programming language to analyze various Python machine learning applications, but also Python as a programming language to develop the platform for supporting our mission. We know that software stacks depend on a lot of components, and software is changing all the time. You can see that there are different layers like Python libraries. Then there are native dependencies provided by operating system in form of RPM packages, for example. But you can also take a look at the kernel space and hardware that is available to run either machine learning workloads or software stacks in general. So you can see a vast amount of platforms and available runtime environments to run your application and to deliver your goals using the given application. So this is like the high scope of Thoth. And while we were building Thoth, we used OpenShift s2i build process. We were happy with it, and we delivered a lot of components using this build process. Later on, we moved to Tekton tasks and Tekton builds. So everything I will speak about also applies to Tekton, and the build process itself is not specific to OpenShift s2i per se, but you can use these container images, like Thoth's s2i container images, to build software in Tekton. We used pipenv to pin software stacks. So when we were developing a component in Thoth, we created a list of, or pipenv created a list of packages that should be installed considering direct dependencies of our applications. And the list that was created out of pipenv is fully pinned down a software stack with all the packages in specific versions that should be installed in order to run an application. This listing lists all the packages, so meaning also transitive dependencies. And this is something you should really do. So you should use software like pipenv to guarantee that your application states all the packages in pin form, so all the versions, and also pipenv produces output that has digests of artifacts that are installed. And with this, you basically guarantee that your application is built always with the same software. If you run it or you build it today or 1 year later, you at least know what were present during the build process when you were developing your application, and software or the tooling that is in the build process can guarantee that there is certain provenance of packages that are installed into the build container image, but also integrity of artifacts that are installed into the container image. However, after a while, we observed issues with pipenv, or we experienced issues with pipenv, and mainly the fact that community was inactive at that time, and it really did not release new versions of pipenv that made community quite angry. And you can follow posts like, if this project is dead, just tell us. That's an issue on pipenv issue tracker, and it was not nice to see. We patched pipenv a few times to make it work for our components in order to deliver or install software into our components. And we produced our own fork of Thoth pipenv. We tried to push patches that we maintain to upstream. Some of these patches were accepted by upstream, and we continued using Thoth pipenv, so our own fork. After a while, the community around pipenv released a new version, but it was quite long time when we had to maintain our own patches and our own patched build process, because the build process that was using pipenv was downloading pipenv from PyPI during the build. So we had to adjust that. When we were experiencing these issues, we realized, okay, so we don't have pipenv, but do we really need pipenv when deploying Python applications? If you take a look at pipenv, it's quite a beast. It has a lot of vendor dependencies, and if you install it, it eats up to 33 megabytes of disk space. This was tested on Fedora 31 using Python 3.6. So it's quite a large project, and it's not bad because it serves its purpose. But on the other hand, for containerized deployments, it does matter, because 33 megabytes in the base container image, which is used as a builder image, matters. So we were thinking about, okay, so let's try to reduce that size, and let's try to ship only relevant parts that are needed. And also, if you take a look at the build process, if you obey recommendations, like every software should use pinned down software stack, then you can think of, okay, this build process accepts already resolved software stack. So if you take a look at how the build process is used, it uses or is done, it uses already resolved software stack that is stated inside pip file log. And all the packages are already resolved. So while installing these packages, you don't need to resolve anything. You just need to, or the build process needs to install software that is already present in a well-documented and well-known format, that is pip file log. So we observe that there is no need to implement resolver in the tool. And that led to introduction to a new tool that is called micropipenv. And micropipenv is a lightweight wrapper for pip to support requirements.txt, pipenv, and poetry log files, or converting them to pip-tools compatible output. This all, as mentioned, was designed for containerized Python applications, but these ideas are not limited to these containerized applications. You can find micropipenv on ThothStation organization in micropipenv repository, and you can find it also on PyPI. The project is called micropipenv. The main benefits of using micropipenv is that there are no more vendor dependencies. Micropipenv is really lightweight. It has just one optional dependency, and that optional dependency is TOML for parsing TOML files like pip file, poetry log, or PyProject TOML. And micropipenv is a lightweight tool, as stated before. You can find written everything in a single Python script that has more than 800 lines of code. And if you also count comments and license headers, it has 1,200 lines of code. So it's really lightweight tool. But even though it's that lightweight, it supports pipenv log files, poetry log files, pip-tools style requirements.txt files, or requirements.txt or requirements.in files, and also raw requirements.txt files, as one would use, for example, with setup PyScript. So one can say it's one single script to rule them all. Introducing one common base tool that can install dependencies from these files also offered an easy to follow installation log. So previously, when pipenv was used, pipenv is quite silent about what's going on, and if it fails, the log is sometimes not easy to follow and not very readable. So micropipenv gave it also some structure, and logs are now easy to process by people, but also are easy to parse using machines that enabled us build breaker analysis in Project Thoth. Okay, so let's take a look at the demo. And we have switched to terminal. I'm in a directory that holds content of a Git repository that is available on GitHub, Predex repository s2i example micropipenv, and there are a bunch of files that I will talk about. So here's the repository. I think the most important file here is the OpenShift YAML. It is the manifest file that states how to build the application and how to deploy it. So you can find route, service, deployment config in here. You can find two image streams. One is s2i Thoth UBI Python 3.6. That's the builder container image that is s2i Thoth enabled, running UBI 8 with Python 3.6 interpreter. Then you can find also s2i example micropipenv image stream that holds content of the build container image that is the result of the build process. Besides that, I will talk about build config. So this build config uses builder container image that is s2i Thoth Python 3.6 as described below, and the resulting container image is pushed into s2i example micropipenv. Here you can see information about additional configuration options that are supplied into the build process. You can find more information in the README file. And besides OpenShift YAML file, you can find also app.py, that is the Python script that is run. It runs a simple Flask application that simply says hello Thoth. There are also log files, so you can find pip file log as produced by pipenv based on pip file, which states just direct dependency, in this case Flask in version 1.1. You can find poetry log file, that is a log file as produced by poetry based on dependencies that are stated in PyProject TOML. In this case, Flask in version 1.03. There are also two requirements files. One is requirements in file that states direct dependencies, in this case Flask 1.1.1, and the corresponding requirements txt file that holds all the dependencies that need to be installed for Flask 1.1.1 stack, together with digests. And here you can see requirements unpinned txt that holds just Flask 0.12.1, so there is no fully resolved software stack. It's just Flask that gets installed. So let's see how micropipenv behaves for different type of formats. Let's also process OpenShift YAML, and by doing so, we should be able to see all the objects created inside an OpenShift cluster, and we should see a build that is triggered. So once we switch to OpenShift's web console, we should see s2i example micropipenv build that is running inside the cluster. Here you can see logs of the build process, and it will take the repository that is available on my GitHub profile. So that's the content you've seen, and we went through it. By default, micropipenv will use pip file log that is present in the repository, and this pip file log holds all the information for installing the dependencies. So here you can see a log that was produced during installation of these dependencies. In the repository that I've cloned, I created also other directories that just contain copies of files. So here we have files that are produced by piptools. So you can see requirements txt file as produced by piptools, requirements in file, and other file that is app.py for running the application. Now I will start another build, but now I will use the current directory that is piptools, which holds piptool specific files for installing and deploying the application. So we should see another build running inside the cluster. When I switch to OpenShift's web console, I should see that the application is retrieved, and I should be able to see very shortly log. So after pip is updated, I should be able to see information that the installation process is using micropipenv, and here you can see corresponding pip file log that was created out of requirements txt file with all the packages that are present in there. So in other words, pip file log here is just another format for describing dependencies as were stated in a requirements txt file. As you can see, the build process is successful, and the resulting container image is pushed into OpenShift's container registry. Another directory I prepared is using files as used by poetry. So here you can see poetry log file by project TOML, and our well-known application.py. And again, I will trigger the build from the local directory, and I will switch to OpenShift's web console. So once the artifacts are uploaded, I should be able to see the third build triggered, and we already see it in web console. So if I click on it and I check logs, these logs will be very similar to the logs we've already seen. So again, there is printed pip file log. So I see all the packages in pin form and in well-known formats that is produced by pipenv, and all the packages with digest. So I can see that the integrity and provenance of packages is guaranteed. Once the installation process is done, the resulting container image is pushed into the cluster container registry that is running inside the cluster. And now I will use requirements.txt files. These requirements.txt file. Now I don't have all the dependencies logged. And again, I will start the build process from this local directory. The requirements.txt file holds just one version of Flask, but Flask has also transitive dependencies that will be installed and are required to run Flask application. So here I can see the fourth build that is triggered inside the cluster, and in the OpenShift's web console I can already see it. And if I click on the logs, I see that the application starts to build, but I see one large warning, that is provenance and integrity of installed packages cannot be checked. The provided requirements.txt file is not fully logged, and as not all dependencies are pinned to specific versions with digest of artifacts to be installed. So here you can see packages are installed anyway. In this case, pip's resolver algorithm is used to resolve the software stack. And at the end, I can see pip freeze, that is the output of command pip freeze, and all the packages that were installed, but without digests and without information about Python indices. Once the build is successful, the resulting container image is again pushed to OpenShift's container registry and available to be deployed. But as you can see, this installation process has drawbacks and is not a recommended way of installing artifacts or installing Python packages. So that was demo about micropipenv and the s2i Thoth installation process. As you've already seen, micropipenv was designed for containerized Python applications, but it's not limited to them. If you have a use case where micropipenv can be useful, feel free to use it. The project is available on PyPI under micropipenv name. You can also find it in ThothStation organization. The repository is called micropipenv. And if you want to install it, you can install it also using DNF. So thanks to Lumir, who packaged it as an RPM, and you can install it using DNF install micropipenv. If you would like to use the version that is available on PyPI, you can install it using pip install micropipenv. Another addition in the s2i build process is a tool that is called Thamos. And Thamos is a command line interface for communicating with Thoth. You can find this CLI tool again in ThothStation organization, but now in Thamos repository. And Thamos is some kind of interactive tool for communicating with Thoth for obtaining recommendations. So Thamos detects your build time and runtime environment and submits this information as an input vector together with information that are required to resolve software stacks, meaning direct dependencies of your application, to Thoth, which does server-side resolution. Check talk that is called reinforcement learning based dependency resolution for more information on this resolution process. In a nutshell, how the build process works. So we have s2i build process that detects where the build is happening, what is CPU what type of CPU the environment offers, together with information about Python interpreter version and stuff like that. This information is sent together with information of direct dependencies to Thoth API, which trigger a component that is called advisor, which computes recommendations. So it resolves software stacks given Thoth's knowledge. And once this software stack is resolved, these recommendations are available to s2i build process, which then installs the recommended software into the container image, and the resulting container image is subsequently pushed to container image registry available in OpenShift, as was seen in the demo. Thamos can be used also from your local machine, so you can install it from PyPI using pip install Thamos, and you can simply generate a configuration file for your Git repository using Thamos config, and then you can issue Thamos advice to obtain information or recommendations on software that you should use. You can follow documentation that is available in ThothStation.ninja, and this documentation will go through parts of Thamos and how to configure it in order to use it. Thoth's Python s2i is available on Quai, so you can find a listing of all the available container images in s2i Thoth repository in ThothStation organization. Some of the container images are listed here, so you can find UBI 8 based container images running Python 3.6 or Python 3.8, or you can find Fedora 32 container image running Python 3.8, or a container image that is based on Fedora 31 running Python 3.7. If you wish to use these container images in a build process, you can follow the demo that I showed you, or you can follow also a documentation that is present in our ThothStation organization in the integration section. You can find more information on Thoth's homepage, that is ThothStation Ninja, and all the sources are available on GitHub in our ThothStation organization. The project Thoth is a project that is in AICOE, Office of the CTO. You can find us on GitHub, as stated before. You can follow us on Twitter for any new updates, and you can also subscribe to our YouTube channel if you wish to receive more information about the project, and also more information when it comes to demos that we do, and also periodic Scrum sessions that we publish on YouTube. So feel free to subscribe and follow us. Thank you for your attention.